I am pleased to introduce our first presenter, Decory Edwards. Decory recently graduated with a bachelor's in economics and mathematics from Trinity University and is also a pre-doc research scholar at Yale University. He's mentored by Dr. Jessica Goldberg, who is an associate professor of economics at the University of Maryland. Welcome, Decory. Go ahead and share your screen and unmute yourself.
Hello, everyone. Can you see me? It says I'm shared, but let me go ahead and share screen with you all. All right. Cool. So, hello, you all. My name is Decory Edwards. My mentor in this program is Dr. Jessica Goldberg. My most recent affiliation is with the Yale SE Prep 2019-2020 cohort. And the title of this presentation is Deterrence of Internet Trolling, Uncovering the True Identity of Users. The issue of deterrence can be captured by the following quote: "The credible threat of sufficiently strong retaliation in response to an attack prevents forward-looking adversaries from initiating hostilities in the first place." There is a rich literature in game theory for modeling these cases of deterrence, mainly because of the strategic nature of the parties involved. Now, as for internet trolling, I use this term to capture the act of using the services of a social media platform. Some well-known examples are Twitter, Facebook, and Instagram, to harass or offend other users of the site. Now, as a user, trolling is reasonably undesirable because the potential to experience harassment on the platform may decrease one's overall experience with the site. And as a site owner, trolling is also undesirable because platforms have the incentive to maximize both the amount of users on the site as well as those users' engagement with the platform services. However, we see in real life that trolling does persist despite these parties' incentive to deter it, which makes this situation ripe to be modeled as a classic deterrence problem. So in this project, I propose a model of strategic interaction for deterrence among the different parties, users, site owners, and potential trolls on a given social media platform. I then compare the equilibrium outcomes of that model when the evaluator has complete versus incomplete information about a troll. Now, the goals of this project are: one, to answer the question of whether or not the equilibria that arise in this model change with the probability of finding a trolling user's true identity, and also to provide an empirical test of the predictions of this model. Okay, so here's a three-stage, three-player model of deterrence of internet trolling on social media sites. There are two principal types: pre-existing users, P, and not, N. Now in this model, I assume that a user must create a new account to troll. So the best way to think about type P users is that these are the users whose first account with the site is not a trolling account. Now, in the first stage, the principal chooses to troll the agent or not. If choosing not, then the game ends. In the second round, after observing the troll behavior, the agent chooses to report the principal or not. And lastly, in the final stage, the evaluator receives the reporting information and chooses either the high or low punishment. Okay. Now, here's the game tree for the model under complete information. I'll give a brief walkthrough of a possible outcome of the game. So in this example, nature assigns the principal type as P, and the principal chooses to troll, the agent chooses to report, and the evaluator chooses the high punishment. So here the principal receives a payoff of 1 for trolling and minus L upper bar after receiving the high punishment. The agent receives a payoff of -1 for being trolled, a payoff of -R for as the cost of reporting, and also minus alpha, which represents the benefit to the agent for the evaluator or the principal, receiving the high punishment from the evaluator. And lastly, the evaluator receives a payoff capturing the net benefit of levying the high punishment towards the principal, and that's represented by tau here. Now, although I don't include the game tree for incomplete information, the game trees are nearly identical and the payoffs actually are the same. So I left it out. Now we get into the theoretical predictions of this model. Note that for the case of complete information, I include only the subgame perfect Nash equilibrium found in proposition 3, because it is the case where the principal chooses a different action based on their type. And for the case of incomplete information, the weak perfect Bayesian equilibrium is included in proposition 4. And this is the instance in which the evaluator's beliefs determine whether or not they choose the high or low punishment. Now, for the next steps in this project, I'd like to provide an empirical test of the model by working with the dataset CrowdTangle, which records a number of metrics such as reactions, comments, and shares at the page, group, and post level for a number of platforms. One of those next steps, if possible, is to identify some proxy for principal type. Now, to conclude, I've proposed one model of deterrence for this phenomenon we've termed as internet trolling on social media platforms. We look at equilibrium outcomes when the owner of a site has varying levels of information about the potential type of troll. Here are the sources that I found most helpful to this project, and I'd like to thank you all for hearing me out today.